Michelle. Thanks for asking this question. And you're right, it's an interesting question. There are lots of different ways to do it, and I don't think there's any one best way, but I can show you how I guess I would approach the problem, and maybe that'll help you. First of all, I just want to say that that is the right equation. That is what I got. And if you graph that, then it includes all three of those points. So you got the right answer. One thing that I thought of that helped me a lot with this problem, made it really simple, is that there's a theorem in geometry called the perpendicular bisector of a chord. I will share my screen because it's a lot of words, but it's easier if there's a picture. So basically what it says is that if you have any 2 points on the edge of a circle, and we know that all three of those points that we're given are on the edge of the circle, if you draw a line, if you draw a chord between the two, and then you draw the perpendicular bisector is always going to go through the origin. So if you have 3 points, then what you can basically do is draw the perpendicular bisector for one, and then draw another one, and you can use that to find the center. That's a summary of what I'm going to try and show with this. So this is the equation that you came up with, which is right, which is, I believe it's x plus 2 squared plus y minus 3 squared is equal to 13. But pretend we didn't know that. Let's just start over. Let's just draw the 3 points. So we know that it has the origin in it, 0, 0, right here. We know that it has an x-intercept of -4, which I've drawn there. And we know that it has a y-intercept of 6, which I've drawn there. So with what we're doing before, let's try and think. So we know that if we draw a line, like the circle's gonna, like if we can just guess, it's probably gonna be like somewhere like that, right? So if we draw the line, a chord between the 2 points, I'll do it in blue here. So that's a chord between these 2 points. Now, if we draw the perpendicular bisector, which basically means it has to be perpendicular to this line, so like it here or below it, anywhere that's perpendicular. But to be a bisector, it also has to be perfectly in between the 2 points. And because it's on the y-axis, it makes it a little bit easier. So we know that it has to be perpendicular to the blue line and exactly halfway in between the points. So we know that that's basically the line right here. And that just happens to be the line y equals 3 with our case. So we know that the center of the circle has to lie somewhere along this line here. That's not enough information. We only have, well, we have a line. We know it's somewhere on that line, but we don't know exactly where. But what we can do is we can do it again for these 2 points, because any 2 points that you pick, if you draw a chord and then you draw the perpendicular bisector of the chord, it will go through the center of the circle. So now we have this line, this chord from here to here. Now we want to draw the perpendicular bisector. So again, we move our ruler like that. We know it has to be perpendicular, and it has to be perfectly halfway in between. So what's halfway in between 0 and -4? It's going to be at -2. So we move our ruler there, make sure it's perpendicular, and then we can draw this line right here. So now we know that the center has to lie along this line right here, y equals 3, and that it also has to lie along this line here at x equals -2. And the only point that satisfies both of those equations, or both of those criteria, is right here. So we know that that is the center of the circle. It's going to be at the point, so this is x equals -2, and this is y equals 3, so this is the point 2, -3. So that's great. We know the center. The other thing that we need to know to define it in equation form, you know the equation, you had it before. It's like x minus a squared plus y minus b squared is equal to r squared. And ab is going to be the center. So we have most of the information. We have ab is 2, -3. So x minus 2 squared. Oh, sorry. X is -2 and +3. My bad. Don't copy what I did. It's wrong. But yeah, negative 2, 3. So we're going to have x plus 2 squared, and then y minus 3 squared is equal to r squared. Well, that's what we still need to find. We're almost there, but we still don't know what r is. So r we know is going to be the same for all the points because that's the definition of a circle. It's all the points equidistant from the center. So we can take any one of these points and just find the distance. So let's just take, I'll use pink. We have that right there. Like that's going to be the radius of the circle. For that, we can just use the Pythagorean theorem. This distance is 2 right here. And this distance is 3 right here. So by the Pythagorean theorem, this is r. R squared is equal to 2 squared plus 3 squared. So r squared is equal to 4 plus 9, which is 13. So all we have to do now is plug that in for r squared, and we get x plus 2 squared plus y minus 3 squared is equal to 13. And if I'm not mistaken, if I haven't made any mistakes, then that's exactly what you got before, right? Yeah. So that's how I would do it. That's the geometric way to do it. And I guess I can just complete the picture to make it a little bit easier to see now. But the circle it's going to be like equidistant from that point. This is a really bad picture, but it's going to look something like that. And that's what we had here from the actual equation with the center at negative 2, 3. Perfect. I hope that helped a little bit. If you have any more questions, you can leave a comment and I can try and explain some more.